And then the third step is that we're going to solve for x. So looking at number 1, we want to isolate the log, and there aren't 2 of them, so that means we don't need to combine anything. If we only have one log or one ln, there's nothing to combine. We basically just want to get that to one side and then all of my numbers to the other side. So if I want to get the ln, or the natural log, to one side, I need to move the 10 over. So I have negative ln x plus 1 equals negative 7. But I don't really like that negative in front. So I can just divide by negative 1. Or I'm just going to erase both negative signs. Now I want to change this to exponential form. So remember that base comes up, and then the 2 numbers, the one on the left and the one on the right, will switch. So the x plus 1 and the 7, they switch places, and the base comes up. Well, what is the base of a natural log? E. So there's technically, it's like saying log base E. So the E comes up, the 7 and the x plus 1 will switch. So I'm going to rewrite it as E to the what power? 7th power equals x plus 1. Now I want to solve for x, so what do? Subtract the 1, and then I am done. So x equals e to the 7th minus 1. And I can't evaluate e to the 7th because it's going to be some crazy decimal, and I don't know what that is. So I just leave it as e to the 7th minus 1, and I am done.
So why don't you divide by x plus 1 with the 7? That's what I just started doing, but I don't know.
Why don't I divide? I just want to get this by itself.
Okay.
And there's nothing to, the only thing that's left is moving that 1 over. There's nothing under the x plus 1, so just move it over from there.
Okay, so we're solving for
X. Okay, number 2, I now have 2 logs, and I want to combine them. What sign is in between them? A plus. So what does that mean I do with the x and the x minus 7? I multiply them. So I write it as log base 2. When I multiply them, what do I get? X squared minus 7x equals 3. I've isolated the log, so the log is on one side, the number is on the other, and I want to change it to exponential form. So what does that look like? These 2 switch, and the 2 comes up. So I write it as, what's on the left-hand side of the equal sign? 2 to the 3rd power, good, equals x squared minus 7x. Now how could I go about solving this? Factoring, yay! Well, I want, whenever I have something like this, where I have an x squared, I want to move everything to one side, set it equal to 0, and then factor it. So what is 2 to the 3rd power? 8. So I'm just going to rewrite this as 8. And when I'm factoring, I need to set it equal to 0, so I can rewrite this as x squared minus 7x minus 8 equals 0. And how would that factor?
Oh, is this the trial and error?
Yep.
Is it plus 8 and then minus 1?
Minus 8 plus 1.
I don't understand how to do that so fast.
So 2 numbers that multiply to 8 and add to 7.
Yeah, I know, but it always takes me a couple tries.
And so what does x equal? X equals positive 8 and negative 1. When I get 2 answers, I do need to plug them in and check. Now, they only will not work when you plug them in to the log function and you get a negative number. Okay? So you can either put them in the combined log, or you can put them in each individual one. Sometimes it's easier for me to put them in the individual ones, but either one is doing the same thing. So in my head, when I put in 8, both logs are positive, because 8 is positive and 8 minus 7 is positive. So that one works. When I plug in -1, I have log of -1. Is that possible? No. So -1 is not a solution.
Can you write out how you plug them in for me?
So I would just put in log base 2 of -1.
Okay. And
You're just plugging it in.
And when the parentheses, anything in there is a negative, it's gonna not work.
Right.
Okay.
So go back
And,
to the original
okay.
equations.
And then if it was if we got a 6 instead of an 8, and the first log worked but the second log didn't.
You're not checking if the answer works. You're checking if it's negative inside the log.
Yeah. So if we got a 6 instead of an 8, the first log it'd be a positive. The second log it'd be a
Oh, then it wouldn't be
So
it would not.
work if-
Yeah, it has to work for both of them. I see what you're asking. It does. Yeah, that's a good question. It has to work for both of
But
them.
since you saw that the first one was gonna be negative with negative,
You can
1,
just stop there.
So
Yeah.
So if one of the solutions is negative, does that just?
It means that it's not. Yeah. So -1 doesn't work.
Okay.
So like automatically, if you see negative, it won't work.
Alright, and
No, because if I had log base 2 of -x and I put in a -1,
It would work.
it would work.
Are we ever gonna have any where
That's
both
what we
work?
just did.
No, we did a positive.
Yeah. So my suggestion is to, like, if I had, and you may not see -x, you may see like 2 minus x or something like that. And when I plug in -1, if I plugged in -1 here, it would be 2 plus 1, which is a positive 3. So that one actually ends up working. So just because you get a negative answer doesn't mean that it doesn't work. You have to think, when I plug that answer into both of the logs in the original problem, does it become negative? Okay. Yes.
So I'm kind of lost where you got the 8. Like I get you log,
I just set these equal to 0.
but like, how did you get? You moved to 3 over.
She did
and
2
what
to
is
the third
third
power.
power is 8. So you don't apply it to the. You're switching.
I have
When
it.
you change it to exponential form, the 2 comes up,
She just.
and then the 3 and the x squared minus 7x will switch.
So the x squared minus 7x is like the.
It's like what's inside the log now. When I change it to exponential form, it goes to the right side of the equal sign.
Okay, so log base 2 to 3, I just make it 8.
Mhm. So, like, if I had an easier example, if I had log base 3 of x equals 5, and I wanted to change that to exponential form, the 3 would come up, and the x and the 5 would switch. So I would rewrite it as 3 to the 5th equals x.
Okay.
So that's all I'm doing on number 2. It's my second step right here.
So you basically are like getting rid of the whole log.
I'm getting rid of the log by changing it or switching it to exponential form.
Okay. That makes more sense.
Okay, let's try another example. So number 3, I've got 2 natural logs on the left side, and then I have 1 on the right side. So let's start with combining the 2 on the left. What would that look like?
24x squared plus 11.
Yeah, ln 24x squared plus 11x equals ln of 18. Now, something that's really nice and is helpful is if you have like a log on both sides or an ln of both sides and they have the same base, then you can just set this stuff inside the parentheses equal to each other. And you don't have to move it over and set it equal to 0 and all of that.
So since they both have the same base of what?
ln.
ln. Like they both have the same base of e.
Wait.
Oh, Oh, because it's log E.
So then it would just be-
But don't you have to factor it?
I do.
Yeah.
Now I do, but I can drop the ln's. Since they're one, it's kind of like equal weight distribution. Since one is on the left and one is on the right, they can just go away.
So how do you factor?
So how do I factor that? I move the 18 over.
Wait, you know what? Don't even tell me anymore. Because
Okay, I'm not going to tell you. I want you to try factoring this.
Stop just giving me the answers. This one can. Trying to learn. Multiplies to 18, adds to 11. Well, that would be 9 and 2.
If you're thinking like, why does this work? It's the same concept as when we have the same bases. So we had like 2 to the x equals 2 to the third. And you know, they both have the same bases. So what does x equal?
9 over 8.
Well, I mean, just up there, it would be 3, right? This is the same concept. Like, I can drop these 2's because I have the same bases. Well, the same thing works here. I have 2 logs or 2 natural logs that are the same, so I can set their insides equal to each other, and that works. It's like I can drop them because they're equal on both sides. So it is the same concept.
Whenever
Just
I did trial and error, I got x equals 9 over 8 and then x equals negative 2 over 3.
I think you have the sign switched. So you should get 8x plus 9 and then 3x minus 2. Because if you add the outside and the inside, you get a positive 27
Oh, because
and a
they're-
negative
okay, yeah,
16.
That's supposed to be on the other side of the equal sign.
So x equals negative 9 over 8 and x equals 2
Yep,
thirds.
I got it now.
When I plug them back into the originals, which ones do and do not work?
2/3 works.
This one works.
Well, it's positive.
It's positive, and then the negative 9 over 8
It's negative.
is negative, so only this one will work.
Yeah, I forgot to do since it's 8x plus 9, I forgot to set it 8x equals 9 and then divide it.
Mm.
That's why I had the sign switched.
All right, so number 4, this needs to have a parentheses if it doesn't, so add that in. Does yours have it?
Nope.
Okay, add it in.
Who made this? I cannot.
And I would like to set the LNs equal to each other because I have one on the left and one on the right, but just looking at it, why will that not work? There's a 3 there. So
Subtract.
if there's if there's a random number in there, then I can't use this nice little rule because the 3 gets in the way.
Oh my gosh.
So what is something that we could probably do?
Subtract.
I could subtract this over here.
Yeah, but then you'd have to divide.
So I've got ln x plus 2 minus ln 2x plus 5. And what did you say, David? What do I need to do?
You have to divide, just for those of you who didn't know.
I've got to divide because why?
That's the rule with logs if you subtract.
Because of that minus sign, right?
Yeah.
So if I combine it, it becomes now just 1 ln with what divided by what?
Hey, let me catch up.
X plus 2 divided by
Yeah.
2x plus 5.
Good. And that equals 3. Have I now isolated the log? Yes. So what is my next step?
You have
Could
That
you
is a good
multiply the parentheses by 3?
We wouldn't want to do that.
Oh, you subtract 3 to set it to
What are we
0.
trying to do?
We don't want to do that yet.
Yeah, David, idiot.
We don't want to do that yet.
Oh, times it by log?
You can't pull anything. Can you pull
You're
out
done.
2?
No, I'm not done.
Can you just simplify it? So
You can't do that either.
would you
Pull
It's already
out the-
simplified.
divide
You
by
pull
the
out the
x?
x.
It's step number 2.
You pull
Go back to your notes. What is step number 2? Change to exponential.
Okay,
Is that
so
even possible?
yes,
Yeah.
it is. Everything is
Oh,
possible.
the
So the Lord who
first
gives me strength.
two.
Philippians 4:13.
Is it ln e? Is it base e?
E to the third.
Wow. Oh, y'all, we totally forgot about this step.
How did I get e to the third?
Because you took the 3 over.
Because this is like log base e.
Yeah, log base
And then
E.
the 2, the parentheses, and the 3 switch. So e to the third equals what?
Negative.
X plus 2
Yep.
over 2x equals 5.
Okay, now
But what?
Now we're done.
Why
e to
is
the
it-
third is just technically a number. It's like 2.7 to the third power. So,
Wait. Why isn't the x plus 2 and the 2x plus 5, why aren't the signs switched since they went to the other side? Of the
because when
equal
you're
sign?
changing it to exponential, the signs don't switch.
Because that would be even the negative.
When you change to exponential, the signs don't switch. But now if I like move this over here, the signs would switch. So when you're just using basic algebra to move left and right, that means it switches. But when you're going from log to exponential to log, the signs all stay the same.
Okay.
All right, now these are similar to number 1 and 2 on your homework check. Solving this equation.
Wait, is
No,
this
we're not done. We got to get x by itself.
Are we supposed to turn in our own
No, you keep it.
Okay, so
Now,
a fraction of
using our butterfly method,
Whoa.
cross multiplying.
Are we cross multiplying the exponent?
Yeah, this stays one, like this stays together. It is one thing.
That was
So it's
tricky.
x plus 2 equals.
Okay, so x plus 2 equals,
2
you got it.
x plus 5 to the third.
Somebody in your calculator type in e to the third power.
no, guys, I got it.
Just tell me,
Okay, now
that might
Mary-
help us
Mary
know
got it.
that it is just a number.
20.08.
20.08. So it is like a number, right?
Okay.
But I'm just going to call it e to the third. I'm going to leave it like it
Is
is.
it like 2xe
So it's like 2x
plus 5?
e to the third, or you could put 2 e to the third x if you want, since it's a number. And I'm going to do it that way. Plus what?
5.
Good. We distributed. Okay. What is our next?
Just- I'm not gonna say that word. I'm not gonna say it. I'm gonna keep working
Do
hard.
you want to get your x on both
I do want to get my x's
So
on.
you're gonna subtract
So
the
x minus 2 e to the third
Why'd you
x
put that?
equals negative 2 plus e.
What's next? And these steps, like once you get this like step-by-step process mastered, it makes everything so much easier because it's the same every time. Pull out the x, and I'm left with what?
1 minus 2 e to the third.
Amazing.
Then you have x
Equals 5.
So I'm gonna erase this right here just to make life easier. X equals, because I divide by all the messy stuff in parentheses.
Negative 2 plus 5.
If all of your signs are flipped, that is okay. That just means that you moved the x over to the other side. And that's okay.
What?
Wait, so why did you? Oh gosh, you subtracted the 2.
So I see that you guys have a blank piece of paper on the left side of your notes, like I guess the back of 8.5. So let's go through the step-by-step process of how we solve these kinds of problems. And we kind of did that last time, but it just needs to stay in your brain. Just needs to stay in your brain. So you guys are good up until the point of when you get to, let's see where we were. We were
stopped
at-
knowing what to do whenever we had to distribute the e
Wait, I
to
didn't
the
even get
third.
So when you had e to the third equals x plus 2 over 2x plus 5.
Let's start there.
Let's start here, okay?
Minus 2 over 1.
So I cross multiply.
1 minus 2.
1
Right.
minus 2.
I'm gonna write all this.
We did, but we're just writing out the steps. If you would like to, then you can. If you want to just follow along, that's fine too. Cross multiply. Get x's on one side. So here and here. What's the next step?
You are a quick one.
Oh, sorry.
You're a speedy little teacher.
Take out the X.
Factor out x. So when I factor out x, I'm left with 1 minus 2e to the third. And then my final step is I divide by stuff in parentheses. And I leave it be. There will be no simplifying after that. Don't keep going. You're going to have this instinct. You're going to have this instinct that you want to like cancel something out. But don't do it. Just don't do
This
it.
is the first time you told us not to go farther.
Nope, you just
Okay, so
stay.
then it's going to be x equals -2 plus
Because you
5
can't do anything
to the
because
third over
that.
1 minus 2 e to the third.
Because here's what you're going to want to do. And you are killing a puppy if you do it. Remember that. You're going to want to do this, e to the third. And you think right now, that is silly. I would never do that. But you will. Just don't do it. Don't do it.
Wait, so you're saying I will? So
Should we write it on the board?
No, it's too evil to write on the board.
no, the
But
little
it's
box
a
that we
smart
put like
corner.
Dylan.
What month?
Susie
What
and
month do we
Dave.
Just
put
divide by sub parentheses, and maybe you should write yourself a big note that says then stop at the bottom.
Oh, hey, it's
So
the barn
final
is-
step
it's
is
the 4-month anniversary.
then
4-month anniversary.
stop.
Oh my gosh, it's the 5-month
Mess up my
anniversary of
smart
barn.
bomb.
So you're going to type in log of x as your first function, and then you're going to type in x squared minus 2 for your second function. Now, if there is no base present, what do we assume that it is? 10.
Are we typing that in?
Yep, you're graphing both of these. What do you mean?
Actually type out
You
log.
type in log.
It's kind of strange.
Wait, no, there's a button.
There's a button for log.
There's also a button. You can do either way.
It's control 10 to the x power.
That makes more
Welcome.
sense.
You're mo-
Do we only need to find the one in the in-
So, in this case, it does have 2, but what do we know about negatives?
We know that negatives
They don't exist.
Well, imaginary.
I finally got it.
I don't really understand what she said before. I just heard
I
negatives.
can't
So.
read my intersections because it's always on top of each other.
Would you like to restate what you stated?
So, we have 2 x values in which they intersect,
Okay,
right?
that's true.
One is at 1.472 and one is at x equals 0. So I have x equals 0 and x equals 1.472. But does log of 0 exist?
I thought
No.
it was 0.01.
No, it should be 0. So your float might be off.
There's like so much to eat.
Like the way that the decimal.
Is there a starting
I don't know.
Yeah, and I'll look at it over.
Okay, so that's just the calculator.
So log of 0 does not exist.
I need to write that down.
So we are only going to use the 1.472.
Okay. As you would.
That's the answer?
Yep.
Alright, we gotta call up TI Inspire about this issue. Because whenever you do the intersection, it really is on top of each other. I don't know what is what.
That's why I don't like that calculator.
Move it.
So which quadrants
Log.
do they
You can
actually
like
take
tap,
answers from?
like
Of
move-
Positive.
little cursor.
does
Like-
Positive x values?
Yes.
Nice.
So basically quadrant 1.
Okay.
exist.
The next example is an exponential. So it can have positive and negative answers because it is exponential. So exponential, it is okay to have negative answers. Logs, it is not.
Wait, say that again.
Exponentials, it is okay to have negative answers.
Okay, we're going. Expo equals negative. That's okay. Now I'm ready.
Alright. So how do we do this one?
Like in the last example, like if I had log of negative x, then I could have a negative answer because that ends up making the log positive. Does that make sense? So I don't want to say you can never have negative answers. You can just never have negative logs. Okay? The reason why the last one did not work is because you had log of 0, which doesn't exist, and then log of negative number, which doesn't exist. So if you get an answer that makes one of these happen, then it is not a solution, okay? That doesn't mean, like in this case, if I had log of negative x, I could get x equals -2, and that would technically work because a negative 2 becomes positive,
Okay.
right?
Yep.
On exponentials, anything is game. Anything works. So I have two intersections, and what are they?
Negative 0.886.
Negative 0.886 and 0.706. Good.
Will it always be 3 decimal places?
Yeah, go 3 decimal places.
This is a hard lesson
Wait,
today.
I thought we couldn't. On my calculator, it only
Exponentials, you can.
It won't show up the line, and the little blue box is checked to show up the line.
You have to just delete the other one.
Those are the points of
final
intersection.
cumulative or just
Mhm.
the semester?
Okay, now on the inequalities, it's the same process, but now we're going to create an interval, okay? An interval just means like from this point to this point. So, on the notes, it says that a function is less than another when it is below that function. So fill in the words below. I don't really want to exit the calculator, so
When it's below what?
below that function. So if you have like a less than or equal, then that means that it's below that. And we've done inequalities with functions before. So this is kind of the same thing, but we're now looking at exponentials and logs.
So these inequalities are only dealing with range, like height, like the y value?
Yeah.
Okay, so you don't have to worry about the x value.
Well,
when
we
you do that.
look at the y value, but we record the x values, okay? So what I want you to do for 6b is I want you to graph both of them, which you already have them graphed, right? Because it's the same as 6.
Mm-hmm.
So we had our answers, and I don't know why I erased them, but I had x equals negative 0.886 and x equals 0.706. And it's asking, so here are my 2 points. It's asking when this red function is below this blue function, if you can see my picture. The blue function is the stuff on the right, and then the red function is stuff on the left. So you can see a visual. So I want this interval right here because it is below the blue. And it is less than or equal to. So I would have
Everyone?
perfect. So it would just be negative 0.886 to 0.706. And would I have brackets or parentheses?
We would have brackets
Brackets because why?
because of the equal.
Because less than or equal to.
You know, I'd like to step out this classroom, and if you guys would like to lift it up to the Lord that David doesn't experience when we start this morning, I would very much appreciate it.
Okay, the next one, so 6c has the same functions, but it's asking when the red is above the blue.
So you do negative infinity, comma, negative 0.886, and then parentheses?
Perfect. So it's everything but that middle chunk. Like it's the two outsides. So it's here and here, right? So then it's going to have two intervals that look like negative infinity to negative 0.886. And would it have parentheses or brackets? Parentheses,
And then
union.
Why would,
706 to
This is 6c. This is 6b. So when it's above, it's like the stuff on the outside. When it's below, it's the stuff in the middle. Do what? You can go. Okay, next one, number 7. It has 3 different inequalities now. So let's graph 3 functions. We're going to graph 2, 3, and log base 3 of x. So I'm going to graph 3 of them and see where the log function is in between those.
So do I literally just type in a 2?
Uh-huh.
I feel like you could do this without it.
I would like to see you try. Log base 3 of x. And I think I'm going to have to go over here.
Yo, I feel like the 3 is kind of ever intersect?
So you put 2 at the bottom?
I guess I need to put y equals 2. Don't know why it's not showing it. There we go.
Oh, it does intersect.
There we go. Okay. I'm going to have to come over here. You might have to zoom out just a tad
Oh.
because it looks like it's at...
It intersects twice, I think.
Yeah, my calculator keeps on giving me a loading sign.
So it's not pulling up. There we go.
Wow.
So once you get your... get your graph here, it's between the 2. What would my interval look like? So when is it between the 2 and the 3? 9 to 27. Would it have brackets or parentheses? Brackets.
So my calculator was like really loading, and I could finally figure it out, but like, because I had to click on each line, would it be easier just, I don't know how to do it without making it like get mad at me for 10 minutes while waiting on it.
I don't either. I'm sorry.
Just is yours?
Maybe like one at a time.
Okay.
I don't know. Okay, so then 7b, it says, does your answer to number 7 make sense? Based on what you know about logarithms. So basically, log base 3 of x equals 2, and log base 3 of x equals 3. When I'm setting them equal to each other, my calculator tells me that this is 9 and this is 27.
Yes.
Does that make sense?
Yes.
How? Why does that make sense?
Because you can, that's when you split them, and you get 3 squared is equal to 9,
Mhm.
3 cubed equals 27.
Perfect, because 3 squared equals 9 and 3 cubed equals 27. So that checks out. So could we have done this without a calculator?
Yeah.
Yes. Tommy wanted to do it without a calculator.
Except like how?
So how? I would just set log base 3 of x equal to 2 and equal to 3.
Okay.
And from here, switch to exponential form. So 3 squared equals what? 3 cubed equals what?
Okay.